This video is going to walk through an example from the Class 30 homework. I'm going to look at this function, the g of x function, and the first thing I'm going to do is to pull up Desmos and graph the function. So I'm going to enter it in. G of x is equal to 2x squared minus 12x plus 18. And here we see I've got my parabola, and the first thing I notice is I look for that vertex. And the vertex is at the point 3, 0. So I'm going to come back down to the table, and I'm going to enter the vertex into the table, 3, 0. All right, the next step is I want to find the points 3 on either side of the vertex. So I can look for 2, 1, and 0, and then also input 4, 5, and 6. Now Desmos has this great feature to help here. I can use my function notation and say I want to input 4 into the g function, and notice it tells me it outputs 2. And when I go back, look, and do you see that little equal to in the bottom right? When I put in 5, the output is 8. And let me go back, and now I'm going to input 2, and the output is 2. All right, that's kind of cool. I see a pattern maybe developing here. I'm going to input 1, and it equals 8. Hopefully you're seeing that little equals 8 there. And I could keep doing this. If I put in input 6, 18 comes out. And if I input 0, 18 also comes out. All right, so that's a great feature in Desmos to get values. Thinking about the axis of symmetry, I'm looking for the vertical line that I can fold that parabola on, and that was x is equal to 3. All right, and that was the graph for the axis of the symmetry. Next, I'm going to go down and use graph paper to actually graph this function. I'm just doing it here. Notice I've made a really big coordinate plane, xy plane, and I'm going to start incrementing. I always increment by ones unless I have a good reason not to. That's my x, and I wrote f of x there, but I really meant g of x. Let me go up my y-axis, and I know for this, I'm going to have to go up more than 18 because when I look at my largest output, I have an output of 18. All right, I'm going to go up to maybe 20. And it's always a great idea to increment all parts of the axes, even though I'm not going to be plotting any negative points. It just helps set the context. All right, I'll start plotting some points. I'll start with 0, 18. Next, 1, 8. 2, 2, and then my vertex 3, 0. Now we're going to start seeing some cool properties of the axis of symmetry. Look how these points are coming in, and then 6, 18. All right, I know it's going to be a parabola, and I'm going to just do my best job to do a fairly smooth curve through those points. It looks like a parabola. Notice it's never perfect, but we get the idea. Right, now I'm going to start thinking about some of the key important features of this parabola. Let's start with the axis of symmetry. And I'm drawing that as a dotted line because it's a feature of the graph, but not part of the graph. You can imagine folding on that line. Another key feature is the vertex, which is the point 3, 0. And that also happens to be the x-intercept, so we'll also identify that. The vertex is really important. Intercepts are really helpful. All right, so we have the x-intercept. Also the y-intercept we have here on the graph, and that's the point 0, 18. So I hope this example just helped you see what the different steps are that I want you to do for all 4 of the quadratic functions.